Yes, all right, it's working now.
All right, working great.
Okay, cool. All right. Okay, so this is not wrong, but I know it by the time I see this, I know that this is not going to do is not going to change the program state at all.
Do you mind zooming in a little bit, Professor?
Yes, let me. So by the time I see this, I know that M0 is going to remain unchanged.
Okay, so
I can just return M0 right here.
Oh yeah, good point.
It's not wrong, but it's just, you know, do it. And okay. Oh,
I think I know what I did wrong here.
no, this is my bad here. This is you're making this a function call to this thing here, and I thought it was part of this thing. So it's a formatting thing. So I misread this. Let's see here. Let me take a look at this. So I'll give you some points back for this. This is, you know, this thing is not this thing, right? So this is undefined here. You think of this as a function with formal parameters. So the variables you have are expression and block, and in the body of the function you reference expr, which is not this. And so I guess I'll give you your, I won't give you your 2 points. This is because of these other, and this thing is also not this. Does that make sense?
Yep.
Yeah.
Okay, so then this is sort of a similar kind of an issue again, right? The computer is going to be really, really unhappy about this. So it's important that we kind of, you know, get really sensitive to it, because in milestone 4, it's a deal breaker. You know what I mean? All right, so let's see. But anyway, okay, so you meant to say this. So you evaluate this. If this is true, then you. So this is also incorrect, because this guy here, this function right here says I take one parse expression and a model, right? Those are my 2 parameters. Yes.
Yep.
And this thing here says I take 3 things that are these expressions. I treat them, I just treat them as root symbols. I'm not going to like look inside them or anything, right? So you pull these out and you call this, right? And then when you're here, you're now building a single parse expression again. So this guy here now has 2 arguments, 1 and 2, where this one has 3 arguments.
Yep.
All right. Okay, so then let's see. So would you know how to fix it? I mean, I can say more about this, but do you know how to fix all of this?
Yeah, that's kind of like what we did, because we shouldn't have put n in there, and we missed the yeah, but I think that's what we did, because we tried correcting it before, but we just wanted to verify before we with you before we move forward.
So what you would be passing here, right, is and again, don't be shy about asking for more stuff. You'd be passing this argument. You'd be passing this argument. So that this is 1 argument, which is this one. You'd be passing 2 arguments, which is this one. And you should make these the right names, by the way. And then you're passing the 3rd argument, which is a state, right? Which is that. Yes?
Yep.
Okay. All right. So if you think of this as as M, and E is the same way, but M right now, since that's what we're talking about, M is one single method in Java, and it has a bunch of if. If the tree looks like this, then do this. If the tree looks like this, then do this. If the tree looks like this, then do this. If the tree looks like this, then do this. Yes?
Yep.
Does that make sense?
Yeah.
So, and what the if the tree looks like part, that's being defined by the context-free grammar, right? Yes?
Yep.
Yeah.
I'm just making sure that we're all kind of like at least understanding that part. So if you change this and you step outside of your grammar in doing so, then if the tree looks like this, then this. If the tree looks like this, then this is not accounted for. This one is not accounted for, I'm guessing. Because it says it's gonna, so show me which one, show me where this matches. Does it match this? No, because a sign is not skip.
Mhm.
Yes?
Yep.
Is there another one? Do you have another one? Is that the only one?
Yep.
That's the only one. So the program will get here and it'll fail.
Okay.
This pattern right here says, I will only match a tree whose leaf says 4, parentheses, and then there is an assignment statement. If there's not an assignment statement right here, I'm expecting to see one I will not match. Then I expect to see a semicolon, then I expect to see an expression like this kind of stuff. And so if you put a skip here, this is not an assignment statement.
Okay. I have a question though.
Mhm.
Did we have the right idea if we had that defined?
If you put that in the in your BNF grammar, and you had an M, another M for for loops that did this, you could do it that way. Where's my pen?
Right. Yeah, because we just went down the list of like, because we just wanted to initialize it one time and then finish the for loop.
Right, but this one is it's harder than it's unnecessarily difficult. And the reason why is like you're changing the structure of the parse tree manually,
Mhm.
right? And that's always a little bit problematic because these things are complicated. So and it's error prone. So it is possible to do it this way if you had another grammar rule that says, you know, so and so. The better one, this is the for loop is the reason why you want to use an N. The while loop is the one where you could use an M. Let me say a little bit more. Let's see, where am I? Okay, so if you have a while, whoops, let me make this a little bigger. How's this? Good?
Yep.
If you have a while loop, right? This, and I do this in the lecture, right? So I actually give you, I believe I give you the solution for this one. A reasonable way to do this is to say, well, I'm going to evaluate the expression. And then if this is true, then I'm going to evaluate the block and then do the whole thing again. And so I can use M for that. Okay, let me maybe make this a little smaller. Maybe I can make it wider. All right. Right. So what this thing says is that if this is true, then evaluate the block and then repeat, right? Else, we're done. Yeah.
Yep.
And actually, so notice that whatever effort you had to put in to create this, you can just copy and paste it down here now. Yeah. Where in the for loop, if you're creating a new parse tree structure that doesn't exist in your BNF, that gets a little scary because it becomes harder to reason about what kind of tree structures are available during your interpreter, are being generated and stuff. So it's sort of a bad idea, but it is doable, right? So yes, you could generally, if you're going to have a grammar where you have rules like this, you're going to need to have, if this is a statement, you're going to need to have n of these. One for each one for each shape, right? So that accounts for all of it. And so if you're generating new shapes as you're executing, that's a little funky. But what I would have done in the for loop, if you wanted to really do it that way, I would do something like this. Loop is keyword for assign opt. This kind of stuff. Block. So where assign opt is either an epsilon, a skip, or an assign. And so, well, you still have to generate an extra tree, but it's a little cleaner. But yeah, I would for the for, I think the easier way to do it is to right. The easier way to do this is to map this to the M part. The M part does this and then calls N with these pieces. So where N has the three pieces. So what N does is it says, evaluate this. If true, evaluate this, do this, and then repeat. And if this is not true, you're done. Where if you do it the other way, you're having to create the thing, but it's not wrong, but it's considered bad form. Anyway, so
Necessarily complicated.
but yes, you can do this, and you technically speaking, you don't even have to have this in your grammar as long as it's accounted for, but that is playing with fire at that point. But yeah, we have to think about larger projects and stuff. Yeah. But anyway, so do you know how to fix this one now? Do you have enough?
Yep.
Yeah.
Okay, cool. This is an E.
Okay.
Remember, things that return expressions return in our world, an expression returns a tuple, which is a value and a state of computation, right? A statement returns just a state of computation. Those are two different critters, and you cannot mix and match those. Does that make sense? Let me show you. Suppose this is a logical OR. Yes?
Okay.
Then I call it with E, but I don't have a definition for E. I only have it for M. I should have called it with M. So you'll never get there. Does that make sense?
Yeah.
Mark? The picture's kind of small, so I don't know if I'm reading you. Do you look confused or?
I guess I thought we were, actually now I'm kind of confused the difference between what we're doing with 13A and B, but I thought we were just like clearing off the
So if you if you are an expression, if you can occur on the right-hand side of an assignment statement, you must, without exception, be evaluated using the function E.
Okay.
Okay, and but if you just so that's just sort of an absolute, but let me tell you why it's a problem, why it wouldn't work if you did it a different way. If you said, again, if I pick here, where is this? If I pick here, if this has a tree that is a logical expression, yes, I mean, if it's a parse tree that has logical expression in it, and you call it with this, then what will happen when this thing encounters the logical expression? It'll say, I'm in E. I don't have any logical expression. That was done by M. So how do they connect? Does that make sense?
Yep.
Okay. It's a handoff. You know, you hand off, E's can hand off to other E's, right? And sometimes you can call, an M can call an E and take some information and throw away some other stuff, you know, so there's connections that you can create, but it has to be a direct, you know, you can't just sort of say, I hope that somewhere in M is evaluating this at some point. There has to be a direct trail from the top of the program. It says, you know, if you look at, like if we drew a tree, a parse tree, you know, however this thing looks, and we start out with M, then we should be able to walk right through it in actual program and say, so M, I call M on the root, it's going to call M over here and E over here, maybe, okay? I'm just making some stuff up. And then this M is going to call this with an M and this with an M, and then this E is going to call this with an E and this with an E. I mean, I'm just sort of tracing through the code. And if you say like, well, but I didn't define this E, I defined this as an M. This particular pattern, this particular shape, I defined it using M. It's like, well, but I'm calling it with an E.
Uh-oh.
I don't think I've convinced you, right? Or have I? Mark?
Oh, yeah. No, you convinced me there. I thought that I can't get my, what am I doing? What's going on with my computer right now? I'm sorry, my connection's just got fuzzy.
No worries.
I couldn't get my milestone one to pull up. What I was trying to look at was
What I did probably, what I think you're remembering, I guess I can only pull up the original.
That was, I guess that was supposed to be the rule for expression.
So what
Cutting
we
into
did,
logical or, but I agree, it should have been an E.
so
I
what
just-
I think what we were talking about. So we have statements and we have a list of them, and we can list them exhaustively. An assignment thing is a statement, a conditional and if then is a statement, a block is a statement, and we have things that are expressions. And so in the statement part, we have this, and then we have a hard line, and then we have expressions. And these up here, so if I say something like if expression, then if this is one of my statements, I want to use the word expression. I don't want to use logical expression. Yeah, here it's a logical expression, but when I have an assignment, it's an expression. So it would be misleading to have the top symbol of the expression grammar be logical expression. It's just kind of confusing. So and so I was recommending we do it this way, but then when you get down to your algorithm for translating those precedence and associativity table stuff, the first one is a logical expression. Logical or whatever it was, right? Now, here's where we get into the weeds, and this is where the precedence and associativity table start helping us write the grammar at this point. Yes, and this thing here was just a connection between statements, which like to read this, and our precedence and associativity table, which starts here. It was just for readability. There was no magic here or anything. But so when I'm over here, right, if I want to evaluate an expression up here, it is, oops, it is that type of a thing. And then what happens is I will have a rule that says here, and it does its thing, right? So this is kind of this actually just directly calls there. So we just kind of walk through here. This is kind of, you go like, oh, I could have made it shorter. Yeah, you could have made it shorter, but it's much nicer, it's cleaner, it's more readable to do it this way, and it's not a bunch of work, right? So, you know, this is nicer. So now here's where things start in earnest for us. But the connection came from here, right? Good?
Mhm.
Yep.
Okay. All right. All right, so do you guys know what short circuiting is? Anybody?
In which context?
In this,
Oh, sorry, I had that covered up by my screen.
oh, sorry, no worries.
Or I mean with our video. What are we looking at?
Here.
Oh, sorry, I looked at this last week. I think what I decided was. Actually, no, we were confused.
Does anybody in the group know?
Yeah, no, I was looking at this with Mark and I was also very confused as to what short circuit meant.
Okay, so short circuit is every programming language on earth, without exception, does short circuiting that I'm aware of. There may be some weird language somewhere, you know, so it may not be 100%, but it's pretty much, you cannot find a language that doesn't do this. It should have been taught in CS1. And let me kind of just walk you through what the issue is. And you probably know it, you know, once I give you this example, and I have given this example, I think, in the lecture as well. But if I have something that says x not equal to 0 and 5 divided by x greater than 2. If x is 0, this is false, yes?
Yep.
Yeah.
And if I go ahead and evaluate this, I'm going to get an exception. And depending on what language, I might crash my core dump. So short circuiting is, if this is false, there's no value on this side that could ever make it better than false. You can't convert it to true, no way. False and anything is false. And so then they just say, if this is false, we're done. Do not look at this one,
Okay.
right? And
That makes sense.
I remember that now from the lecture, but
Yeah, I just didn't remember the term for that.
right, it's an important thing because it is a source of errors, right? So if you type this type of, you do a conjunction, right, in an expression, I would say most source code analysis systems will flag it as a warning and say, are you sure you know what you're talking about? Because of these kinds of issues, right? So in math, they both evaluate, right? But in this one, only one does, right? And it is an important thing because this thing could in effect be something that's preventing an infinite loop from happening. If the value is positive, then call this function, then take the square root of it or whatever. You know what I mean? So it shows up in a lot of places and is important. And again, it's universal for all programming languages. If you ever find one that doesn't do this, you know, shoot me an email because I'd be interested in knowing. All right. So you got to do that you got to fix this. And so the way you fix this is you basically say in this let block, you evaluate the first one. And then in the in part right here, you say if this is true, then we're done. Else, and then you create another else, then I got to evaluate this. Good. And then it's flipped for ands, right? If this is false, then I'm done. Otherwise, I got to evaluate the second one. Yes,
So is that the same thing wrong for both of them?
correct. But they're
Okay.
flipped wrong, right? One of them is true or anything is true, and the other one is false and anything is false. So
Yeah.
the idea is the same, it's just opposite. They're the negation of each other, right? They're the dual. The logic term for that is dual, right? They're the dual of this. But yeah, same idea. Okay. Let's see here. And then this one here, remember what goes here is a parse expression. So something that is a parse tree, right? And so in milestone 4, it literally will be the parse tree produced by the parser. It's a think of it like an object, right? So you can't just like my object, you can't just say negative my object. So you have to, so say that again.
No, my wife just walked in. Sorry, she's taking the baby.
Okay, that's okay, that's okay. He's very cute.
Thank you.
You want this?
All right. Okay, let's see here. So, okay, so let me switch. All right. So for evaluating a unary minus, right? Something like this, right?
Did I close that?
Yeah, that's sort of what it is. So first of all, I recommend you do the let in end like this. This allows me to do vertical checking, where if I put the let over here, it's just, for me, it's more cycles from my brain to have to track stuff. It's easier for me to track it this way. I'd like to think that's sort of universally a true thing as opposed to just a me thing. But anyway, so what we're going to do, right, is you're going to say like, well, first evaluate unary. Right, so that says evaluate this thing, and then what it's going to return a value, right? We're assuming everything is well typed because our type checker is going to assure that. So this is going to be a number. And then I'm just going to return the negation of that number, right? And so this language right here, which we're doing all of this stuff, this is for now it's sort of a pseudo language, but it's SML, right? And this is pretty much pure SML except for this part. And so if you think just sort of a normal, a regular programming language, like what kind of operators do you have? And you're like, yeah, you got the normal stuff. You know, we got like if then, we have declarations, we have identifiers, we have all the arithmetic operations. So then I would just do this. Let's see. So that's what I'm returning. So I hand off the evaluation of this to my assistant, and then my job is to do one more computation. I'm going to add one more computation to this, and that is this. Does that make sense? And in SML, just if we're heading, so this is perfectly fine for milestone 2, but for milestone 4, the unary minus in SML is a tilde symbol. All right. The same. Oh, yeah, and negation, right? So it's the same thing for this one too, right? So same idea, basic, right? You just switch the operators. Yes.
Yep.
Yep.
One's for Boolean, one's for integer.
And then exponent.
We didn't. Oh, this one we supposed to be
Yeah.
value.
You can't, so you can say, let's assume there's a library that does exponent, right? So that's typically, if I was going to map these ideas onto a job into Java, right? Translate them into Java, I'd say like, well, there's some exponent library, or maybe I write my own for this or whatever it is, right? And so it's okay to say like, look, at this stage, I'm not going to implement that kind of code that's low level, or I'm just assuming these functions exist. Because remember, SML is a Turing complete language. It's a general purpose programming language, which means any computable function can be expressed in that language. So I'm not going to worry about exactly how that happens right now. I just want to say like, so what I might do for something like this is you had what was like base, something like that, right? And then I will say let end. And then I'm going to, there's a question here, like, if this is right associative, shouldn't I evaluate this first?
I think so.
Right. Think about what this means in the presence of side effects, right? If I have right, that is some jacked up stuff right there. And so so it is, do we, if we do this first, then
Like
this
it's
number
worth
is going to be different. If we do this first, then these numbers are going to be different. So it's a real issue. I don't get too picky about this one because it's sort of subtle, but yeah, right. I mean, at the end of the day, right, if you're an adversary, you start looking at stuff like this, right? You see, like, where is this? Where can I break it? What are the cases? What are the implications? But so it, and I think on top of it, to make matters worse, in Java, I believe that when it's confronted with an expression like this, it doesn't have right associative operators, but I can put parentheses in there to make that happen too. You know what I mean? And so you can see, like, are parentheses really right? So does that change? What it tends to do, if I remember correctly, is it will find out where these references are, and the more touch them, use of that object or that class, and that triggers some stuff, and then I go through and evaluate it, sort of the second. So it happens a little bit, not in a way that you would expect, and in most cases it doesn't matter. But if you look at Java secure coding, right, they'll tell you stuff like this. But anyway, so we will. All right, I'm going to be a purist here. We will do the exponent first. Okay, so we evaluate the exponent. We evaluate the base. And now what I need to do, so this is work that somebody else had to do. This is work what somebody else had to do. And my contribution to the computation is this, right? That's my contribution. And so I'm going to say, well, suppose I have an V2, V1, M2, where X is an exponent. Something like that. And then in milestone 4, you have to decide how you're going to do this, right? You can write it yourself, or you can look for a library function that does exponents of integers. Usually exponents do involve floating points, stuff like this. So you might have, if you use a library, you might have to deal with that. But this is all milestone 4 stuff. For us here, this is fine. You could also have just done, an alternative would have been Um, You just say like, hey, when the time comes, I'm gonna have to implement this in milestone 4 in some way, this computation, this function. Yes? Good.
Mhm.
Yep.
Okay, and then, so that takes care of that. Same thing again, right? So you can't, this is a parse tree. You can't just sort of say this parse tree less than 0. Just like you can't say an array is less than 0,
Mhm.
right? Or my object is less than 0. You can't do that. So what you need to do is get the value that's associated with this there. And then I'm going, oh, and then here. No, this is not a Boolean value. Well, no, so you can't do it this way. And this is an interesting thing. If you wanted to write a parse tree that did this, it would be enormous. Because remember, this thing here starts as a logic, or whatever, a relational thing, which is an arithmetic thing, which is a multiplicative thing, which is a unary thing, which is an exponent thing, which is so that parse tree you would have to, in milestone 4, you'd have to explicitly write that. You'd have to create that. So you do not, even if you could, right, you do not want to do it. And so the way to do this, right, is I get this value.
So V1 is expression 1, and then compare V1.
Yeah, so we have something like, and this is vertical bars here, right? And clean this up. So V1 is expression. And what is the contribution of this? The contribution of this is making this value positive if it needs to be. So I'm going to say here, I could do something like if V1 greater than or equal to 0, then what I'm returning is V1 M1, right? Absolute value of it is equal to this. Else, what I need to do is flip it. There. Good?
Yep.
Yep.
All right. Oh, and then you forgot ink deck down here. Do you have it anywhere?
Yeah, we did all 4 of them.
Where are they?
I can tell you, let me tell you what number they are. They are, oops, wrong mouse.
Yeah, so you did them as M's. They need to also be E's.
Oh, okay.
They're both, but the way to do it is to only implement them once, right? So what you do is you implement them as E's. So I'm assuming you know how to implement them as E's, but if you have a question about that, let me know. And then the M of
We implemented them as M's.
yes, but let me show you the better way to implement them as M's once you have them implemented as E's. So E is the trickier one because okay. So this thing says, hey, go evaluate that. And I have the E that does this. So this is where I'm switching. Notice I'm switching from here to here. Yes, I'm handing it off. this thing still is an M, and it was called, it has to return only an M, right? So what I'm gonna return is I'm gonna say, hey, because I'm an M, I don't need this. This is not, statements don't have values in that sense, right? So I'm gonna just return this. Now, on the E part, I do need to know this, right? So let's just take a quick look. So what you would do here, right? So it is true for all of these that you return this, right? You do this thing, and this is what you return, because what you're saying is, hey, in the future, if you ask, what is the new value of this ID, right? But when it's an E, in the case where this is an E, this one says you return the value and then you increment it, right? Where this one says you increment it and then you return the value. Does that make sense?
Yep.
Okay, so that's the thing that you have to be careful of on the E's, right? Because it does matter. And then the M just says, I throw away the value. I don't care what it is. Just give me the change in program state. Just give me this. All right. And I think we just, oh, so that was it then. Yes. Okay. So that's all. All right. Any questions?
I guess I just had a question about the survey. There's a
Okay.
milestone 2 survey in Canvas. It says it's missing, but it like closed last year.
Oh, I think the survey, yes, I guess I should make it available. It's not a graded thing or anything. I'm trying to remember what it asks. I think if I'm correct, if it's one of these things that the administration wants us to do, and it's like, is the pace of the class too fast or too slow? That type of a thing. It's something like that.
Okay.
But I'll take a look at it now, and I will hold on. So it's not, there's nothing important other than sort of, providing that kind of feedback. So we said the survey. Oops. Oh, no. Oh, sorry. This is a participation one. Sorry. So this one is asking, like, is everybody in your group pulling their weight? But yes, I will make it available.
Oh, is that participation in milestone 2 thing? Because I have one that's like dated like last year, which
Yeah, that's
obviously
what I was
doesn't make
saying.
sense.
That's what I
Okay,
was
okay.
asking
You weren't able to access the survey though, right?
No.
Okay, yeah. So it's not a rush. So, but thanks for bringing it to my attention. So it's out there, and the reason why is this may or may not be a surprise to you all, but groups sometimes are dysfunctional, and sometimes people. I have meetings with people where they say these 2 other people are not showing up to anything. They're not doing anything. What do you want me to do? This kind of stuff. So this is trying to get some sense of the room or of the class regarding that metric. Yeah. So I think I have another survey later, but it's at the end of the semester or something. I don't know. But yeah, so it's not like a survey that has to take place, that you have to take before the exam or anything like that. And I will make it available. I'll put on my to-do list for tomorrow and stuff. Good.
Okay, and then I guess just while you're here, for assignment 3, we're just turning every single one of these rules into a type checker, or
yes. So
okay.
you want, if these are correct, right, then the other ones are much easier done, right? So the main thing about type checker kind of stuff is you sort of say stuff like, hey, if I'm adding 2 things together, go get the type of both things And if they're both ints, hey, then I can add them together and get an int. So and so because I don't care about the value, the specific value, I can do this statically, right? This is something you can do prior to, which is a super, super important thing, right? And so, yeah, so it's the same thing. It's just you don't need much of a calculator to do it.
Okay.
So good. Yeah, so assignment 3 is just doing that. It's usually, I like to think it's fairly manageable. You know, there may be a couple places where we make mistakes, but it's fairly manageable. And if you disagree, let me know, right? But yeah, so anything else other than that?
No, I'm good if they are.
Okay, any other questions, anybody?
No, I
No,
think I'm good.
All right, okay. Happy Halloween, y'all.
Happy Halloween.
Happy Halloween.
Thank you.
Peace out. See ya.
Thanks.
Thank you.
You're welcome.